Let's see how to model a quadratic trend in EViews. So now you have both time and time squared. This model will be able to capture some of that quadratic features in your data set if it exists. So if you look at US retail sales, there seems to be a slight curvature. So there is reason to try out a quadratic model to see how well it fits the data. So the entire data set goes till 1994 January to 1995 January. Some part of the data is used for in-sample fitting, and then some part is left for out-of-sample evaluation. And then the forecast horizon is from 1995 January to 1996 December. Okay, let's go back to EViews. You can see that the range of the data set has been increased till 1996 December. Okay. We had previously tried a linear trend. Now we are going to be generating time squared. The time variable is already there. So now time underscore squared is equal to at trend to the power 2. You can set this as at time square. If you wish, you don't have to use this at all. You can directly input at trend square in your estimated equation box. Okay, so now we have our time squared. We can go ahead and estimate our quadratic equation. So you can see the sample is till 1996. We should change that. All right. RTRR, C time, and then time squared, the new variable that we created. There you go. Changing the sample till 1992 December because that's our in-sample model fitting or the training data. There you go. You have your model for time and time squared, so our quadratic trend. Let's look at the residuals and the fitted to see what it looks like. Let's go to residuals. Right, there you go. You can see that this pretty much fits the data pretty well. There is some curvature there in the error, but apart from that, it seems there isn't any distinctive pattern after 1995. Let's go ahead and forecast. This updates every time. So for the in-sample, we will forecast till 1992. So 1954 January to 1992 December. Forecast and actuals. Uncheck the box. Okay. All right. So there you go. So this is our in-sample forecasting. The green line is the actual data. The solid blue line, that's the forecast. And then you have the forecast intervals. Let's record the in-sample squared root mean squared error 2716.626. That's the in-sample root mean squared error. Okay, so we have the in-sample. Let's try the out-of-sample now. Forecast. Change the forecast sample from 1993 January to 1995 December, 1995 January. 1993 January to 1995 January. So for this, we have the data, so this enables us to do some model evaluation to see how well it fits. Uncheck this box, forecast and actual. Okay, there you go. So that's our actual data. The green line, the solid line is the forecast, and then you have the forecast interval band. Now we can keep a record of the out-of-sample root mean squared error 3953.513. Okay, let's go back to forecast. This time we're going to be forecasting the including the entire data set, including the forecast horizon. So I've saved it as quadratic. So you can see it's the entire. This time check the box, insert actuals for auto sample, and then forecast and actual. Okay. Alright, so we have the entire data series from 1954 to 1996. You can see the actual data stops here, but the forecast carries on beyond that point. Okay, let's go back, freeze this graph, and name it. So this is our quadratic forecast. And let's name this. So we have this graph, quadratic forecast. And then set a display name, retail sales quadratic trend forecast or quadratic forecast. Okay. There you go. You have your quadratic trend. Okay, let's go back to our estimation and then record some of the key statistics. So adjusted R squared. Let me put both EViews and Excel in the same space so you're able to see better. Okay, copy, paste, adjusted R squared, Control C, AIC, Control V. And then SIC, Control C, Control V. Okay. If you see the adjusted R squared for quadratic trend is higher, the AIC and SIC is lower, so are the root mean squared errors compared to a linear trend. So it seems like the quadratic trend is a better fit for retail sales. Let me show you another way to estimate this equation. So you don't have to insert time. You can just enter add trend. It does the same thing. And then in place of time squared, you can also enter, for that time squared variable, add trend squared, or add trend times add trend. So you don't have to generate those time series. Like you don't have to create those variables. Okay, so those are not necessarily needed. Sometimes it's handy to have it, but if you just want to do a quick check, you are able to do it with just using trend and a trend square. Let's save this as the quadratic equation, quadratic underscore EQ. This will save our equation. There you go. Now you know how to model a quadratic trend.